There are a number of ways a magnetic field can be used to generate an electric current, and here we illustrate one of them. We start with a bar magnet and note the magnetic field lines emerging from its north pole. Nearby is a helical coil of wire with an iron core, which serves to amplify the effect. The ends of the coil, which is electrically insulated from the iron core, are connected to the inputs of an ammeter, which is set up to measure the current through the coil. When there is no relative motion between the magnet and the coil, the ammeter reads 0, indicating that no current exists in the coil. However, when the magnet moves toward the coil, a positive current I appears, but only while the magnet is moving. As the magnet approaches, the magnetic field B that it creates at the location of the coil becomes stronger and stronger, and it is this changing field that produces the current. The increasing strength of the field at the coil can be seen as the increase in the number of magnetic field lines that pass through the coil as the magnet approaches. When the magnet moves away from the coil, a current is also produced, but with a reversed direction noted by the negative value. In this scenario, the magnetic field at the coil becomes weaker as the magnet moves away, and the number of magnetic field lines through the coil decreases. Once again, it is the changing field that generates the current. A current would also be created if the magnet were held stationary and the coil were moved, because the magnetic field at the coil would be changing as the coil approached or receded from the magnet. Only relative motion between the magnet and the coil is needed to generate a current. It does not matter which one moves. The current in the coil is called an induced current because it is brought about or induced by a changing magnetic field. Since the source of EMF, or electromotive force, is always needed to produce a current, the coil itself behaves as if it were a source of EMF. This EMF is known as an induced EMF. Thus, a changing magnetic field induces an EMF in the coil, and the EMF leads to an induced current. To summarize, a current appears in the coil only when there is relative motion between the coil and the magnet. In other words, a current appears only when the number of field lines that pass through the coil changes. This is called an induced current. The relative motion also produces an induced EMF, which is the source of the induced current.